Hello and welcome to Intro to Exponential Functions. We're going to look at 4 exponential functions here today, just looking at the graphs. The first one is y equals 2 to the x. We've got the points already listed out here. So we see that when x is negative 3, y is like 0.125, it's very, very small right there. Y says negative 2 is 0.25, and negative 1 is 0.5. These aren't even good because I can't even make them small enough. But 0 is 1. So actually it should have been like here, and then 0 is 1, 1 is 2, 2 is 4, 3 is 8, and you can see what's happening, 5, 6, 7, 8. This line, this curve, is going right through 1 and then taking off and getting big. Now if we make it just a little bit bigger, 3 to the x, same thing's happening down here, to be very, very small, very close to 0, very, very close to 0, very, very close to 0. 0 is 1, and you notice that happened here. 0 is 1. 1 is 3. 2 is 9. Up to about there. And then 3 is 27. That's off the graph. So again, we've got this. It's kicking up and going off the graph, way up there. Okay, so if you notice the things that are similar between these two, they are never going to hit 0 here. There's an asymptote here at y equals 0. Same thing here. Never going to touch it. It's going to get closer and closer and closer. So the domain is all reals this way and all reals this way, negative infinity to positive infinity. The range is 0 but not included all the way to positive infinity because it's going to keep going up. One of the things that I hope you might see is that this number is 2. When x is 1, y is 2. When this is 3, when x is 1, y is 3. We've got this kind of thing here where we've got 1 comma this number. We refer to this as b. 1b is true in both of those. And we always have a y-intercept of 1 in both of those. So those are some of the things that are the same. One of the things that's different is that this one's a little bit steeper because the number is a little bit bigger. So the bigger number makes it a little bit steeper. As we look at the next 2 graphs down here, 0.5 to the x, when x is negative 3, it's 1, 2, 3, 4, 5, 6, 7, 8. Negative 2, 2, 3, 4. Negative 1 is 2. 0 is, there's that one again. And when x is 1, ooh, we have 0.5, that's kind of the same. So when x is 1, we've got 0.5, and then it's getting smaller and smaller and smaller and smaller and smaller. And we would call this an exponential decay, because it's getting smaller and smaller and smaller. It's also approaching 0. It has an asymptote here. The domain is all reals. The range is 0 to infinity. And it's getting smaller and smaller. It has a y-intercept at 1. And when x is 1, y is 0.5. This one, when x is negative 3, it's 1.9. 1.9 right about there. X is negative 2, 1.5. X is negative 1, 1.2501. And then, 0.8. You see that? And then 2. This one's actually coming in a bit fatter. And it's still approaching 0, but it's never going to get there. So as this number is closer to 1, it's making it a little bit fatter. This number is a little bit closer to 0, it's making it a little bit steeper. So hopefully you see the difference. When these numbers, you see these numbers here are both less than 1, they're between 0 and 1, it's exponential decay, it's going down. Decay is always something that's doing a shape like this. Whenever this number was bigger than 1, like 2 or 3, it's going up. It's exponential growth. So we always have exponential growth. If that number is bigger than 1, exponential decay if it's between 0 and 1. Here's the general formula. Y equals a times b to the x. When b is greater than 1, it's exponential growth. When it's between 0 and 1, it's exponential decay. If it's negative, it's all different. We don't need to worry about that. So a couple of different things we can identify. The growth or decay factor is always this number b. The rate of growth or decay, the rate, when we talk about rate, how much is it going up or going down? If it's decay, it's how much less is this number than 1. So if I have a decay rate, if this is like 0.9 to the x, then the decay rate is actually how much below 100% is it? And it would actually be like 0.1. But if I have it above, it's like 1.2, we would say then the rate is just 0.2. How much above 1 is it? Basically, this is saying how much above or below 1 is this number here. And then the initial value here is A. When we talk about money invested, this is our starting amount. So, 2 examples. Y equals 3 times 1.8 to the x. So is it growth or is it decay? This number is bigger than 1, so it is growth. What's the initial value? Well, that's the number here. That's my A value. That's how much I'm starting with. Growth or decay factor is this 1.8. It is a growth factor. And the rate, how much above 100 is it? How much above 1 is it? 0.8. Okay? In this one, this is a less than 1 problem here. So this is a decay. The initial value is 2. The growth, or it's a decay factor, and that is this 0.94. And the rate at which it's decreasing, how much less than 1 is this? 1 minus 0.94 is 0.06. So that is my growth, or that is my decay rate. Intro to exponentials.